Hi everyone.
Hi, sir.
So in this video we are going to discuss about design thinking based steady state analysis in control systems. Generally the steady state analysis has been referred with the help of errors, because the errors only the thing which will be notified to the control system unit for making the process. So it has been generated based on the desired output and defined output. So difference between these errors has been identified with the help of this steady state analysis. So moreover, this analysis will be very useful to identify the concept of the corresponding static and dynamic unit, because if it is found any errors in the desired unit means then we need to check the corresponding errors through the entire unit. So it will be very useful to know about the concern problem of the concern unit, and moreover it will define the accuracy of the unit also. So let me see how this unit will be modified with the help of design thinking various 5 stages, and how it is communicated with the help of this design thinking unit.
About the first stage of design thinking. First stage is synthesis. In this stage, we are going to focus on the steady state error effects, position, velocity, acceleration in the real world application.
So because these three things are very essential for any type of control units.
So in one of the example is in the industrial robotic arms. Mainly the operators noticed that the arm was exactly doesn't reach the position. So it is a position steady state error, and slightly slower than the command, because and also it is
because the position itself we know that which type of information it just move towards the destination, so that the user has to identify very clearly,
and also shows some sudden jerks to the during the motions. So by this we can understand what are the effects were affected by this by the arms.
Yes, sir. Next in the define part. In this empathize part, we have only listed about what are the problems here. But in this define part, we have clearly need to know what are the problems actually. For example, I already said that actually Monisha said that there are three main problems such as position errors and also in the velocity errors, acceleration errors are there. So what is the common problem in the position error? For example, when we taking in a example as an elevator, as an we know that lift. So when we traveling on the lift, in this we need to minimize the zero state error. For example, when the lift moves at the top to bottom, when it reaches the ground floor to the first floor, it opens the door when it before the 2 centimeter. So the zero state error is maximized here. So next up we are move to the position error. From this to next velocity error and acceleration error.
So in technical terms they are defined as position as 1 by 1 plus kV, so that the type of error has been notified with the help of this technical expressions, and 1 by Ka, 1 by kV is corresponding for both the acceleration and velocity for making the expression, or moreover it will communicate to the technical expressions.
Yes, sir. So that basing on the technical terms, we can classify our errors, sir. So we need to know about the common classification between the velocity and acceleration. Actually, we know that velocity is a common term. What the speed actually we are moving on. But acceleration is that in how much time it takes to change the speed. For example, we take the automatic Tesla cars. When it reaches from, we set the automatic cruise control to 100 km per hour, it moves closest to the 97 km per hour. So it is maximized based on the nearly 3 centimeters 3 km per hour more than or less than. It can be based on this velocity error. Same this to the acceleration error. It can be maximized that when the speed changes. For example, if we set the cruise control as a 50
because
km
each cruise control having some different default values. In autonomous cars, it just make it by themselves itself. It may create the corresponding values of the gear, so that it will move towards the destination.
Yes, sir. As Sir said that in automatic cars, the gear is manufactured by the default value. So based on when we travel on different roads like slopey, hilly areas, the default value cannot be reached by us. So in the slope areas, it can set us a 50 km per speed, but it is not enough for us to climb the slope areas. So it can be varies.
Yes.
So next we are going to see about the ideate phase. The main motto of the idea phase is to provide a brainstorming idea for the problem that we are facing in the society. So here we are going to see about the robotic arm and the automated Tesla cars and other automated vehicles that is used in the societies. So in this part where it is
based on the derivative function, they are using
Yes, sir.
proportional
Mainly they
derivative
use-
controllers. They are going to assign for autonomous car also, and automation works, so that they can able to catch the process very smoothly and accuracy.
So here we are going to use about the PID, that is the positional integral derivatives, where it is mainly used for in the XY axis also, and it's mainly used in the automated phase. So it is used to
So
calculate the
probably we are going to verify the errors, so
Yes, sir.
so that we can able to modify through this system unit.
So it has been modified with the help of the steady state errors in the functionalities of the object that we use in the industries. For example, in a robotic arm is for particular position or angle it need to be get rotated. So for that it will be get a trial and error method. So by using that we can rectify it. And in automated mobile and automated industries, it you mainly need to have a shoot time and accuracy, speed and acceleration of the all the parts, spare parts that is be using in the things. So with the help of this we can get modified it, and based on that we can make much more better than that.
So the next stage is prototypes. In this stage, the selected ideas are implemented using a simulation or embedded control system. So first, it is about designing the PID controllers for those three loops. First, acceleration and velocity and positions. Next, simulating unit impulse.
So once the information has been processed by using the above three factors, then we need to check the corresponding factors through this autonomous cars, as well as the static and dynamic units.
Yes, sir. As you said, stimulating a unit impulse signal and for position and ramp signal for velocity and
So because
parabolic
these
for-
three factors only define the cars
for the precision and
acting
accuracy.
as-
So next, these are all the actions, and to say in a real example, in a self-balancing robot like a hoverboard or a swing, they are manufactured under cascaded loops. So they can be.
We can able to verify through this.
So those three loops like acceleration, velocity, and position work together to maintain the stability and reduce the steady state error.
And also increase the accuracy.
Yes, sir. Accuracy and precision.
Now I'm going to explain about the testing space. So after designing the system, we just don't assume it works. We want to test it under the real life conditions to make sure that system gives accurate output and the steady state error is smaller, nearly to zero. So the first test is position tracking accuracy. In this test, the system should reach exactly where we command it to go.
So
if
it
we
is
set-
comes under type 0 system.
Yes, sir. If you set the position, the system should not overshoot or stop at the wrong place. The next test is velocity regulation.
Type 2 systems.
Yes, sir. The next test is velocity
So
regulation.
technically they are expert as S into the concern transfer function unit. Yes.
In this, the system should maintain a constant speed without any fluctuations. So the speed should not stop or increase unnecessarily. The third test is acceleration
So they are
smoothness.
mentioned as S square into transfer function of the
Yes,
system,
sir.
so that it will indicate to the users the correct precision mode.
In the acceleration smoothness, when the system is starting or stopping, the motion should be very smooth. So the sudden jerks or shakes can reduce the performance of the system and can damage the systems. So these tests helps us to confirm that the system is accurate, reliable and stable under real-time conditions and operations. For the real-time example, we can take the electric vehicle. So whenever the electric vehicle is going uphill or downhill, it should maintain the constant speed without any steady state error. So and also whenever the driver applies a brake, the system the vehicle should stop exactly at the required distance. So the motion should be very smooth to make sure the passengers feel comfortable and safe.
Okay, so we have discussed about the various stages of design thinking, and moreover, it is comes under position, velocity, and acceleration process. If the process are very good in any control system unit, then no need to worry about anything because of these are the factors which will define clearly to the communicate to the end users. So in future, the applications like automation and autonomous cars, they are using more conscious about this design thinking process, so that it will be very useful to the users. Thank you.
Thank you, sir.
sir.